Hello there, welcome to Proper DIY. If you're like me and when you get somewhat wound up by, then you need one of these. So today I'm going to show you how to install this incredibly easy outside socket, which I think anyone can do. It's not only simple, but actually you can control it remotely. This is the external socket I'm fixing today. It's a 240 volt double socket, which is also IP66 rated, and that means that essentially you can fire water at it from a hose from a few meters away for a few minutes and it should still be okay as long as you install it properly. It's got a couple of nice clips at the bottom that keeps everything tight. Now I'm going to be installing this in around about this position. The other side of the wall is this, which is my boiler room stroke storage room, and as a cable comes through the wall and then round the skirting, we're going to terminate it here with a simple 13 amp plug and then eventually put it into this socket. Now there's a number of reasons why this is absolutely the best way of wiring up an external socket, some of which I'll come on to later. But the first reason is, during all of this, we don't have to worry about isolating this socket. We don't even have to touch the consumer unit, or fuse board as some people still call it, because all we're going to be doing is putting a 13 amp plug on the end of our cable and putting it in that socket, halfway between my water pipe and my gas pipe. The only problem is that I haven't got a drill bit long enough to go all the way through my cavity wall, and I don't want to buy another one. This is around about 340 millimeters thick, so what I'm going to have to do is start in with a small drill bit, drill from either side, and hopefully they'll meet in the middle. To do this, I carefully set out the hole positions using offsets from my gas and water pipe that run either side of the wall, and also made sure that the drill bit was absolutely level when I drilled. I'm finishing here with an 18 millimeter hole. So that worked first time, which I was really pleased at, without any camera trickery as well. So I've just put this piece of conduit through the wall here. It's not actually conduit, it's plastic pipe that can be used for water pipe instead of your copper pipe around your house. It's 15 millimeter PEX pipe. So if you're trying to find it around your DIY shop, look in the plumbing department. So the next thing I've got to do is to fit this back plate of the socket. So I've just knocked out the knockout point. Now I need to offer this up to the wall and drill some holes. I'm using my Marksman marking tool here to show where I need to drill, although using a pencil would work just as well. Then standard raw plugs with a 6 millimeter drill bit. On the inside, I then trimmed the conduit to length. Before fixing the back plate, it's important to seal between the conduit and the wall with a silicone sealer to stop any rainwater getting into your house. I'm forcing the sealant firmly into the hole here so I get a really good plug, maybe 20 or 30 millimeters deep, down into the gap. The only drawback to this is you'll find about 50% of the material comes back out at you. With the house sealed, I now need to seal between the conduit and the back box. So I run a big heavy bead around the knockout hole, big enough for it to squeeze against the wall when I offer it up. I can now permanently screw the box to the wall using external rated screws, or else I'll get black streaks coming down the wall in the future. I can tell you that from experience. And then I can squidge even more silicone into the gap around the conduit and the box, making sure there are no voids left between the two. So that's the back box fixed, and what's quite nice about this design is the screw holes are actually in a different enclosure to where the electrical is going to go, and there's also this seal that goes around the outside, which essentially means that the screw holes are well sealed away from the electric, so I don't think I'm going to get any water through those holes at all. So just before we move on, I have to mention this little drain hole at the bottom, which I've not opened up. And if I read the instructions, it says, should the particular requirements of your installation require a drain hole, you can actually open it. I don't think I do require a drain hole. The whole unit is sealed. There's no moist air coming in for condensation. And the important bit in the instructions is the bit that also says, if you do open the drain hole, you're going to compromise the IP rating of this socket. So I've just paid a lot of money for an IP66 socket that will no longer be IP66 if I drill out this drain hole. So please comment as much as you want, but this drain hole is staying sealed and this unit is staying IP66 rated. On the inside of the wall, I installed a shallow surface mounting back box with a blank plate, just to make it look tidy, but you really don't need to. And that is level. Excellent. Okay, so that is all the difficult stuff now finished actually. Now becomes the fun stuff, which is wiring up for the electrical, and it's not difficult in any shape or form. We don't need to do that outside. We can actually wire up the socket inside. So I'll be doing that in the garage, and I'll show you how to do that on the workbench. So back in the workshop to wire our socket together. Before we start that, we need to prepare our cable. And obviously the first thing we need to do is take off this insulation from the outside. Now, unlike a plug, on the back of a back box, I like plenty of insulation removed so I can work with it, around about 200 millimeters, which is going to be about here. The way I like to do this is to kink it over and with a Stanley knife essentially score the surface. Now I'm not actually cutting all the way through, I'm just making a very, very light score. If I go all the way round, the last thing we want to do is actually cut all the way through here. Go all the way round. I've scored all the way round now. Now, if I actually start manipulating this, you can see the insulation breaking and it's coming apart. And if you do that enough, essentially you get to a point where the insulation is now broken off and I can strip that piece of outside insulation. And that means that I've not damaged any of this inside insulation. If you have damaged any of this at this point because you've cut too far through, you really need to cut this off and start again. But that looks pretty good to me. The brown is live, or line as our electricians like to call it. The blue is neutral, and the yellow and green is earth or ground or CPC, depending on your background. So the next thing to do is obviously to take off the insulation on these cables as well. And there's fairly different ways of doing this. If you've got a pair of wire strippers, I'm aiming for about 20 mil off of this, and I'll tell you why in a minute. Wire strippers are obviously the easiest because they do the work for you, and that makes life pretty easy. If you haven't got wire strippers, the other traditional way of doing it is using a pair of pliers, and this normally takes a couple of goes before you can strip the insulation, and it's obviously a little bit harder. That's a fairly traditional way of doing it. But if you haven't got wire strippers, the way I like to do it actually is back with your Stanley knife again, aim at where you want to cut it, and basically roll the knife around the insulation. It doesn't take much before you get close to copper, and in the same way as the outside insulation, the inside insulation essentially breaks off. You can just remove it with your fingers. Now, these lengths of these towels may look a little bit excessive, but the reason I've cut them that long is that in colleges these days, young electricians are told to double these back on themselves before they go into the terminal. So that's the way I'm going to show you how to do it. I'm not quite sure what's happened to all those ones that I've done in the past which I haven't doubled back. Maybe they've all failed, I don't know. But anyway, so that's our cable ready to get wired into our socket. Back to our external socket, and you'll see here, hopefully you can see, we've got three connections here. We've got L for live or line, N for neutral, and we've got an earth down here. Now normally they come already closed, so the first thing we need to do is actually open these screws to allow the cables to go inside. Then with our cable, we'll start with the live which is the brown, as I said first, simply goes in there. Not too far, because I don't want to be biting down on insulation, but far enough that I can't see any copper. And this has to be done up fairly tight, so we don't want any resistance. There we go. I think really neutral next. If these aren't done up tight, what you find is that there'll be resistance, electrical resistance between the connector and the cable. It will then pull more power and heat up. And any heating of an installation like this is what we call not good practice. That's when things melt and go pear-shaped. So, those are the three connected. You can pull on them and they're fairly rigid. So now we can go back to the back box and install this. This is an easy job, just to feed the cable down the conduit until the socket can be screwed temporarily in place. Any external electric installation like this needs to be protected by an RCD breaker for your own benefit and to comply with UK regulations. Newer properties like mine have this installed within the consumer unit. If you don't have this, then a standalone unit can be inserted between the plug and the socket here. Or, even better, you can purchase an external socket that comes with an integral RCD already fitted. Link in the description below. I completed pulling the cable through the box on the inside, which essentially fixed it in position. So I could then return to the socket and also seal between the cable and the conduit, so no moist air from the inside of the house can get in. I'm using my hammer here as a length guide just to space the cable clips evenly as I run it along the top of the skirting. I can then cut the cable to length and install the plug. The cable I'm using here is 1.5mm squared flex, which can take up to 15 amps, hence safe, as it will be protected by the 13 amp fuse within the plug. So that is the plug installed at this end of the cable. And before anyone comments on these cable clips, yes, I did put them in upside down on purpose. I wanted this cable to be resting on the top of the skirting here, and I can get it resting if I put these upside down. You can comment if you want to. So electrically, I'm now complete. There's just one last thing we have to do, and that's just to test it with our simple 240 volt tester. So if I turn it on at this end, we can go and test the socket. I've already mentioned a couple of times that I think this is by far the best way of wiring in an external socket, and there's lots and lots of good reasons for that. Firstly, as I've already said, I didn't have to isolate this or even touch the consumer unit to get to this stage. Secondly, if you don't trust your neighbours not to use your free electricity when you go on holiday, or if there's a problem with the socket and moisture has actually got in, all you have to do is... And that socket is now isolated from the rest of the house and can't be used by anyone. But the best thing about wiring it in this type of way is that we've now got a plug and a socket within this circuit. So between this plug and the socket, we could actually put a smart switch controlled by your mobile, or another more basic switch controlled by a remote control, or even a timer. That means that we can now control that socket as we want. And that gives us lots of possibilities, which means that we can do things like this. Now these are just garden lights I've just set up temporarily. I'm just controlling them from this remote control. Personally, I would put these on a timer, which means I wouldn't have to worry about remembering to put them on every night, and also they could turn off when I went to bed. But we can use other garden lights, such as Christmas decorations in November and December. They could come on late afternoon and go off in the evening, or even this could control the fountain in your pond to aerate the pond. That could come on and off a number of times during the day. And I'm sure you can think of other things in your particular circumstance that this will be useful for. So I hope you've enjoyed this video. If you have, please check out the other ones on my channel and please subscribe. Lots more coming like this. So until next time,